Hi, IB. Welcome to Chapter 8 as we head into trigonometry. And I'm sorry you have to excuse my voice tonight. It's almost gone. Um, but just taking a look at 8a, which is your radian measure, this is just a summary of what we were supposed to get out of looking at designing your plate today. And if you were very neat with your plate, then you will have a fantastic reference for the rest of this chapter. We measured out our radius. We took the radius and we basically ticked along the circumference of the circle every time that we measured out one length of our radius. And we pretty much discovered that one radius length is close to 60 degrees. It was approximately 57 degrees. And it doesn't matter the size of the circle, doesn't matter what radius you use, because it's always proportional to the radius, right? So as you have, it's like a similar triangle. This is similar circles. As your circle gets smaller or bigger, this angle stays the same. Therefore, this ratio stays the same with your radius. So size of the circle doesn't matter. And we wind up seeing that 1 radian, denoted by this little c, we'll use that later as well, is about 57 degrees. If you drew your plate through the entire first side of that activity, you would have wound up marking all of the pretty much the special angles that we're going to use in the next couple chapters. These are the angles that we need to know by heart when we break down our circle into intervals of 45 degrees, which are denoted in red. The green is 60-degree intervals, and the blue is 30-degree intervals. And we're really just counting fractions. So if our blue is 30 degrees, and we basically took 180 degrees and broke that down into 6 pieces to get 30. So we took pi and divided that into 6. So if pi is 180 degrees, divide that by 6, we get pi over 6, which is equivalent to 30 degrees. So we can talk about degrees and radians now as sizes of angles. And if we take this blue pi over 6 and we count by pi over 6 around the circle, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6, and we can continue to do this until we get back to 12 pi over 6. Now, obviously, we can reduce this down because 12 pi over 6 is the same as 2 pi. Similarly, 2 pi over 6 is the same as pi over 3, and so on and so forth around the circle. However, we just want to make sure we're recognizing that those are the same angles, the same measures that we're actually talking about. So if I say 2 pi over 6, we can also call that just pi over 3, which is a better way of describing it. And we can do the same for the green pi over 3s. Here's 2 pi over 3, 3 pi over 3, which is really just pi, 4 pi over 3, 5 pi over 3, 6 pi over 3, all the way around the circle. And same with 45 degrees. So if you take 180 and you divide it by 4, you wind up with this 45 degree, or pi over 4. So just make sure that your circle is updated and reflects our special angles that we are going to be using a lot over the next few weeks, this week, and then when you guys come back from break. So just to summarize what we wound up measuring today, when you wound up cutting your string to match one radius, and then we wound up ticking around the outside, there's maybe 1 string length, there's 2 string lengths. 2 radians was really 2 times your radius when we're talking about length. And what we measured was that actually comes out to be about 2 times approximately 57 degrees. So if we want to know about how much that is, we can just double 57 degrees, and that gives us an approximate answer. When you wound up measuring 3 radii plus a little bit, it's not going to line up exactly, that gave us a semicircle. So that wound up being 180 degrees, or pi, which we're going to call pi is our radian measure, 180 is our degree measure. And when we divided it down, so if we divide 180 by 3.14, or 180 over pi, we wound up getting approximately 57 degrees. So 1 radian wound up being about 57 degrees. And if we went all the way around the circle, we wound up getting 6 and a little bit, which was 2 pi. Now, when we talk about circumference, we've known circumference as 2 pi r ever since, probably primary school. But 2 pi, if we use our radius as 1 unit, which is the smallest circle that's comfortable to use, then it'd be 2 pi times 1 as our radius. So we can, again, the size of the circle doesn't matter, and we can say 2 pi times whatever the radius size is, and that's how we're sort of bringing ourselves back to what circumference is, which is really 2 pi times your radius. So we were told this as a fact in primary school, and now we kind of should be elevated to the next level to know a little bit more about where this all comes from. So therefore, if we know 180 degrees is equal to pi radians, 1 degree would be as if we divided by 180. So we would get a pi over 180 for our radians. You can write RAD. And if we have 1 radian, so if I want to reduce pi down to 1, I divide by pi. So I'll get 180 divided by pi, and then we'll be left with our degrees. Therefore, to convert radians to degrees, we multiply by 180 over pi, and to get degrees to radians, we multiply by pi over 180. So therefore, when we're asked to write an exact value, 90 degrees will be exactly pi divided by 2. And if we round it, it would be approximately 1.57 radians if we used our 3 significant figures. And you guys might write radian or RAD, or you might use this little C symbol you'll see in your textbook as well as radian. 270 degrees would be 3 pi over 2 exactly, or if we round it off and we leave an approximate answer, that would be about 4.71. All right, so we will prefer to leave exact answers. However, if you are allowed to use your calculator and you round it, just make sure you're using 3 significant figures for your radians. Go ahead and pause the video here and just try these 4 on your own, because we'll be trying these when you come to class on Thursday as well. And then go and push play to check your answers. So just think about number 3 and 4, 5 radians. You would be pretty close to coming back around to a full circle. So 286 degrees, you'd be down in the 4th quadrant. 15 radians, you'd have to go around your circle several times to get to about 859 degrees.